Shut up and sit down.
Okay, welcome to part 4 of the CNC build video. We're back in the CAD. So I'm busy with the headstock design. I want to get this finalized because next weekend I am overseas, so I need to get this made this week if I can, or as much of it as I can this week. So I've got a 3-phase 0.75 kilowatts 2-pole motor. It is an 80 frame with a B14 mounting face. This model is actually pretty accurate to the part that I have. And these are J-section pulleys, 80 diameter and 40. So it's a 2-to-1 ratio, so I should end up around 6,000 RPM on the high end and 500 on the low end, while still maintaining a good amount of torque. This is just that cylinder that I showed in the last video. It's a 50 diameter piston. Only needs about a 50 stroke, so what I'm going to end up doing, I believe this is the same length as what I have, I'm going to cut it shorter, shorten the shaft because it's only pushing, and it will retract, and I'll put a spring on my lever to make sure it retracts. So the plan is to have, just align this over here, I'm going to have a pivot point as close to the center of the drawbar as possible, and what I'll do is this will push up. So I'm using the large side of the cylinder, gaining probably a 3-to-1 mechanical advantage, or 4-to-1, and that will push down on the top of the drawbar, and that will compress the washers and will unclamp. So it's using a small cylinder, pretty compact, to achieve quite high forces. If I pop over into the model, the enclosure has been redesigned a bit. Let me turn off our mark. Yeah, the enclosure's had a bit of work done to it. Also added an electrical enclosure. There's our mark. There we go. Okay, so we've got the chip tray at the bottom there. That has been manufactured. Just needs to be screwed together and probably go for powder coating next week while I'm away. The head over here, so it's all pretty compact actually, in line with the electrical box. Everything is biased to that side. That I can fit an 80C because I need one of those, don't I? Then that is the TTS style holder or flange that are being manufactured. That'll butt up against there with the slot for the tool changer. Yeah, the rest of the machine hasn't really changed all that much. It's just, oh geez, that exploded hardcore. I need to go back in and unbreak that. Oh geez. Okay, I need to go and just rigid group that whole. Actually, I don't think I can do it here. Use spindle mount, rigid group, yes. Continue, yes, continue. What the hell? Control Z. Cancel. Well, this is interesting. Capture position. Yes. Rigid. Okay, there we go. So that's now fixed. So now if I move it in the model, it's hopefully not going to explode. Yeah, so the motor is very big in proportion to everything else, but that means I got lots of power. Yeah, so chip trays at the bottom, electrical enclosure is on the side here. I'm going to put my power switch over there somewhere, and then I've got a backplane that removes. These covers are going to change a little bit still, especially the big covers. This is just a temporary getting the feel for what I want to do design. But yeah, that's the evolution of it so far. Now we're going to go over to the workbench, and we're going to go over the electrical placements and what I have planned for that. And off we go. Cabinet, where we're going to mount all the things and just going over what's going to actually be in here. So here we got an oscillator that I scavenged off of something. It's a 3-phase oscillator, 3+ ground. I'm going to run it just on 2 phases because, well, my live and my ground, because my whole machine runs on 220 volt single phase. But that will be my main oscillator. It looks really cool. Then over here I have got my fancy Chinesium VFD 0.75 kilowatt. Then I've got a Meanwell 350 watt. Oh, it's not a Meanwell, it's another brand now. 350 watt 24 volt power supply. That is sufficient to drive my 3 main axes. My 3 main axes should pull 12 amps peak. Leaves me with a 2.6 amp headroom for solenoids and anything else. But if I do add another axis, which may be planned, I'll be having to put in a second power supply. So I'm going to make a backer plane to hold these using those mounting holes. So what I'll do is I'll make a backer plane for 2 and have that screw on with external screws, so I can pull the whole plane off, add in another one, slap it back in, sort out the wiring, be done with that. Oh yes, by the way, this is the same size as the VFD will be. This represents the brain box and the Mach 3 breakout boards, so I'm going to be using grbl to start with because it's what I run on my own machine. I kind of like it. We'll see what it can do regarding feeds and speeds with the precision I want. Worst case, I will just change up to something else. So I've got a Mach 3 breakout board, and then I'm using an Arduino there, do a custom little DB25 pin. The reason I'm doing that is that I can get a 0 to 10 volt out for my VFD. Also have a relay on there, so it's less things I have to do custom hardware for, and at this point that'll do the trick. Over here I have my x-axis, which I own already. I need to still order my y and z axis. The invisible fourth axis will stay invisible for the meantime. This is a 120mm fan. I'm going to replace it with an 80mm because I've got 80mm, it's just not here. The idea is to position it like such that it will pull air from the bottom past the drives through the heat sinks of the others, so we'll have constant airflow through all the drives to keep them cool. The reason I have all these cutouts is so that I can position them and see what seems like it's going to work for us. So I've got the VFD and the power supply on this side to try and keep the high voltage over to one side, and try and keep the 24 volt and brain box stuff on the opposite side. I have got some terminals which I'll probably be using to manage my heavy duty power. These drives, the plan is when I need to move the machine, I'm going to unplug from here, pull out my encoder, pull out my 24 volt. My 24 volt will probably go from here to a terminal row with breakout, so I can just loosen those off, pull the plugs out, pull the plug out, feed it back out, and it goes. I'm not going to be running my step and direction via any specific terminals. I think it's stupid to add another point of failure. I'm going to go straight to the Mach 3 breakout board, so I might actually run JSTXH plugs because my board has that, and just run these each straight to there and just plug them straight in. I should have some of those laying around, otherwise I'll just get my hands on some. The Mach 3 board is a 5-axis breakout. grbl only supports 3-axis, so it'll be 3-axis to start. That will then have a relay on it. That relay will be responsible for my coolant. I think there's only one relay on it. That will handle my coolant. I'm going to have to add a second relay to handle my direction of my spindle, because that is rather important. I may run that relay for my direction of spindle and just a separate coolant line, I don't know yet. But the coolant will be, I want to put mist, I want to put flood, and I want to put air blast. So what I may end up doing is having a selector switch on the panel of the machine. So the idea is to use my screen of my laptop over here, boom, boom, mount that to an arm, and then on that have a couple buttons to stop the machine, and e-stop, and then my coolant override, so manual override for it, potentially feed rate override. It's just some of the nice to haves, and in there I'll have a selector switch to select what kind of coolant I want. So the grbl will turn the coolant on and off for me. It's up to me to select what I want. So if I want flood, if I want air blast, if I want mist, I just select, and the signal will go via that switch, and that switch will send it to which solenoid it needs to go. I have got some solenoids. I'm thinking of mounting them at the back of the machine, making a section for my pneumatics to go, just so it's not in here. I don't really want it in here. As it is, there's air moving in. Yeah, I don't want wet air in here. The plan is to have all my cabling coming out of this corner here. My in cable will probably come in along the bottom here. My high voltage will run along up to the switch, out of the switch to terminals there, and then feed into my power supply and my fancy Chinese VFD. That will then handle my my high voltage. From there my 24 volts will come here. My high voltage for the motor will more than likely run right around back and up here, just to keep it as isolated as possible. These will probably end up moving up a bit just because I want some isolation, but this is the basic layout for now. This is what is planned. I'll have some terminal blocks here, the high voltage terminal blocks there. Also need high voltage to power my laptop. It's got a generic power brick, so I want to run a cable down the cord, down the tube. That'll be mounted right at the laptop. But yeah, that's the electrics for now. Now to the exciting stuff. Let's just adjust the camera here. She came home. That is the base of the machine. It's on a trolley for now, and then some wire that I salvaged out of a machine we were stripping down. So I've got some quite high core count, decent size wire that I'll use to run my axes and limit switches and things off of. And then that guy is going to end up on that table, and that table is going to end up where I'm standing, hopefully tonight, because that trolley has to go back to work tomorrow so that I can bring the next piece home and work on the frame. So the plan is to have the frame in here by Monday next week, have the chip tray inserted, the electrical box inserted, start assembling the linear on the base. And then there's the old CNC for reference. This one's work envelope's a little smaller, but much more capable machine. And anyway, thank you for watching. Please do all the things, like, subscribe, rate, do the stuff.